This is our ServiceMonitor. And the ServiceMonitor is a crucial component because it tells it here, I know where this application is. Prometheus, here are the metrics. Hello everyone and welcome back to my YouTube channel. My name is Anais Urlichs, and in this video I'm going to walk you through how to get started with Kubernetes, installing Prometheus and Grafana to visualize metrics from your application inside of a Grafana dashboard. I'm going to take you from having Kubernetes cluster to installing Prometheus, accessing the metrics from your application. So basically these are the metrics that are produced from my application. I can access them in Prometheus and then I can visualize them in a Grafana dashboard. Now these are the metrics of one of my GitHub repositories. I'm going to show you how to set up the Kubernetes cluster, how to install Prometheus in Grafana, how to install this metrics exporter that allows you to access the data through the GitHub API in Prometheus and Grafana. And I explain all of the different components in this tutorial. Whom is this tutorial for? Well, it's for both those of you who already have experience with containers, container orchestration tools such as Kubernetes, maybe even monitoring tools such as Prometheus and Grafana. It's also for people who are just getting started with all of these tools. Now, if you've never used Kubernetes, this is going to be a very steep onboarding curve, and that's okay. You don't have to understand all of the different moving parts and components of this tutorial. This tutorial is supposed to provide you with a starting success experience in the cloud native ecosystem. Now, once you've completed this tutorial, you can then dig into the different components and the related tools that I'm mentioning throughout this tutorial. For those of you who prefer the written version of this tutorial, as always, I've created a blog post for this video tutorial first. And this is a very comprehensive blog post that details everything that I'm doing, all of the different components I'm using, all of the different commands. So you can also copy paste commands right from the blog post. You can see additional graphics, additional explanations. You can find also additional resources to other videos on my YouTube channel, as well as to videos from other people in the space and other blog posts and documentation resources from across the space for those different tools that I'm using and detailing in this video. So do check out the blog post. It's linked below in the description. Now, as you can see, this is a very comprehensive blog post. It's over 3,000 words long. And as you can imagine, it takes a long time to create this content. So I would highly appreciate if you could subscribe to my YouTube channel right here on YouTube. Hit the subscribe button to stay up to date with my content and support my content. And maybe you also want to give this video already a like, a thumbs up, to make sure that other people can see this content as well. Also, if you're interested in free online learning resources from across the space, have a look at my weekly DevOps newsletter, where I share basically free online learning resources, updates about my life and from different people in the space, inspirational content from Twitter, career-related content, and much, much more, including events and, of course, my tweet of the week with something interesting or funny. So do check that out if you're interested in my content and you want to support my content further. Okay, the very first thing that we have to do is we need access to a container runtime, to a container engine, something that can run our containers. Now, in this case, I'm gonna go for Docker Desktop. Here you can install Docker Desktop either through Windows or through Mac. There's also a Linux version. Now, I haven't tried the Docker Desktop on Linux yet. If you're on Linux, you can also just use Docker CLI, the command line, to run and manage containers. You don't need access to the desktop UI. Now, you can go ahead and you can install Docker Desktop from the official Docker documentation. Now, once installed, you should be able to access Docker Desktop. This is the UI, and the UI basically allows you to manage containers, container images, volumes to your containers, dev environments. I haven't actually checked that out yet. And you can add extensions. So you can basically check out the different extensions. We also have from Aqua Security, we have the Trivy extension right here. So if you're interested in container image vulnerability scanning, check out Trivi. Anyway, so this is everything you can do within Docker Desktop. You can see here, I have Docker Desktop, the container engine running. You can also, within the settings, you could spin up a Kubernetes cluster right here. That would be one way to go about setting up a Kubernetes cluster. Now, we're not going to use the Docker Desktop Kubernetes cluster because I want this tutorial to be more accessible across different environments. So we are actually going to use a KinD Kubernetes cluster. At this point of the tutorial, you should be able to open your terminal. And you should have Docker installed. So you should have access to the Docker CLI within your terminal. So you should be able to run Docker version, for example, and see the version that you have installed within your terminal. So make sure you installed the right version and you can actually run Docker commands. Additionally, you could try to run a Docker container from the Docker Hub. Now, the Docker Hub provides basically a way to store container images. So container images are basically instances of an application that is not running. Once a container image runs, it becomes a running container. Now, you could check out any container image, for example, the BusyBox container image. You could select the BusyBox container image and actually pull the container image and then run it. Now, it's part of this tutorial. We are not going to go into detail on how Docker works and how we can run and manage containers with Docker directly, but you could learn more about Docker and Docker container images first before proceeding with the rest of this tutorial. So again, this tutorial is really providing you kind of a starting point with the different components and where you can set up things to have your first managed running application. Now, if you never use Docker or other container runtimes, container engines, then I suggest you to take now some time and just look at the Docker documentation, look at other content related to Docker, and familiarize yourself with different commands first. So now we have Docker installed. We want to install a tool to actually create a Kubernetes cluster. And for that, we're going to use KinD. Now, KinD stands for Kubernetes in Docker, and it's basically a Kubernetes cluster that runs within a Docker container. So as you can see, this is ultimately how it looks. It will spin up a container image, a container, on your container runtime that you have installed, such as Docker. And then within that are all of the different components that we need for Kubernetes. Now, within the quick start, you should find a way to install it. You can use brew, homebrew, that's the way that I use it. You could also use for Mac, you could use this version, or you can use on Windows, you can use Chocolatey. I don't know how to pronounce it. Now, before we're going ahead and installing KinD, we also need another tool installed. And that tool is specific to Kubernetes called Kubectl, also pronounced kubectl or kubecontrol. And Kubectl allows us to communicate between our terminal with the different components of our Kubernetes cluster, with the Kubernetes API. So go ahead and install Kubectl. Also, the link to the installation is linked below in the description. Make sure you choose whatever operating system you're using, and you're installing the right version for kubectl, also called Kubectl. Now, at this point of the tutorial, we have Docker. We have access to kubectl, right? Kubectl version. And then we have access to KinD. Now, this is important that you both have access to kubectl and KinD, because now we are going to create a new Kubernetes cluster with KinD, with Kubernetes in Docker. So we're going to say KinD create cluster --name tutorial. And you can give it any other name that you like. You can also use your own Kubernetes cluster. So this is going to create now a one-node Kubernetes cluster. I'm going to show you in a second what that actually means to have a one-node Kubernetes cluster. As you can see, this is Kubernetes version, or the node container image that KinD is using is version 1.27.3. Usually that corresponds to the current Kubernetes version that's used across the space. Now, if you have both kubectl as well as KinD correctly installed, what will happen is that KinD automatically connects your cluster with kubectl. So if you say kubectl, kubectl get nodes, you should see your one node KinD Kubernetes cluster running. When you go to your Docker desktop, you should also be able to find the new container image for KinD. Where is it? You should find it somewhere here. KinD in use. Let's check that out. So here are the different one node Kubernetes cluster. Here's our tutorial control plane. This is our Kubernetes cluster. It's running as a Docker container ultimately with KinD. Now, we don't treat it as a Docker container. We're pretending it's our Kubernetes cluster. So I have access here to the nodes. And in this case, it's a one node cluster, right? It's just one node, one container image that's running, or one container that's running on Docker, and it's pretending it's my Kubernetes cluster. Now, in larger environments, if you want to have higher availability, you would usually not run one container image or one node, one node as your Kubernetes cluster. You would run multiple nodes as your Kubernetes cluster. You would want to have a minimum of 3 nodes. So if one of the nodes in your Kubernetes cluster dies, you have the other two to connect to. Now, these are additional details that we're not going to really explore in this video, as this is an end-to-end tutorial on setting up your first application on Kubernetes. However, again, in the blog post and in the description are further resources where you can learn more on how you actually optimize then your Kubernetes environment, your Kubernetes infrastructure. Now, how kubectl connects with the cluster is through a kubeconfig file, and that's in the config directory. So you can look at your kubeconfig file in the kube.kube/config. Well, it's a file, right? And you can cat it, or you can look at ls and then in the kube directory. Now here you will find the credentials to your Kubernetes cluster. It's stored in this file ultimately. So you want to make sure that if you can't connect to it, then it might be that the path to your kubeconfig file is not specified within kubectl. So at this point, we have our Kubernetes cluster. Kubectl get nodes. You can write it out as in kubectl. I just have a shortcut where I can say just get nodes. And then within here, within our Kubernetes cluster, we have different namespaces. Now, these are the different namespaces. If we say kubectl get namespaces, we see all of them. These are all default namespaces that come as part of our Kubernetes cluster. So we have our different kube namespaces with the different Kubernetes components and our local storage namespace as well. Now, right now in our default namespace, we shouldn't really have much in it. Kubectl get everything in namespace default. Now, the default namespace is usually not used. You wouldn't use it. It's bad practice to install things in the default namespace because you can't delete it. So if you're installing new applications, you would create a new namespace. So at this point, we can say kubectl create namespace, and we're going to call it demo. So this is our demo namespace. Additionally, we want to create a monitoring namespace. So kubectl create namespace monitoring. Now, if we now look again at our different namespaces, kubectl get namespaces, we can see that our demo and our monitoring namespace has been added to our list of namespaces. Now, currently, there's nothing in our demo and our monitoring namespace. If we say kubectl get all in namespace demo, then there are no resources found. There's nothing yet installed in it. However, if we install something, it's self-contained in that demo namespace, meaning if something goes wrong, we can usually delete all of the resources that we installed to that faulty application by deleting the namespace. Now, we're not going to go into detail on how that works and the iffy-gritty details that we might run into when things don't get deleted. But for this tutorial, for the purpose of this tutorial, we assume that if you delete a namespace, you delete everything within that namespace. So in short, namespaces are basically logical divisions within your Kubernetes cluster that allow you to divide your whole cluster, your whole Kubernetes cluster into separate components. Now, these components are just logical divisions. They are not physical divisions. They are not new Kubernetes nodes. So for example, in our Kubernetes control plane, in the different namespaces that are specific to Kubernetes, we will find these specific components that make Kubernetes possible. It's the API server that allows us to, through kubectl, to actually talk to Kubernetes. We have etcd, which is a local data storage. We have a cloud controller manager, kube controller manager, a kube scheduler that's basically responsible to schedule our containers that we install with Kubernetes YAML Manifests to our cluster onto different nodes. Now, additionally, on each node, we have more components that make it possible to install different components, different container images on those nodes. If you want to learn more about the different details of everything that runs within your Kubernetes cluster, the different components, what they're used for, and more related to Kubernetes and the underlying architecture, then I highly suggest you to check out this live stream I had with Hannah, where Hannah went about all those different details, gave detailed explanations within her presentation on Kubernetes. So do check out this live stream, it's very useful. Now, next thing is we need to install Helm. So Helm is basically a package manager for Kubernetes. Why are we installing Helm? Well, some applications are very, very big within Kubernetes. They are large. They are like hundreds or thousands of lines of YAML and maybe 50 different YAML manifests that are used to manage that application. So there's lots going on. And we don't want to install and manage individual files. So Helm can allow us to manage an entire application as like one package. So if you're familiar with NPM for node applications, if you're familiar with, what else? What are some package managers? Oh God, no, I can't find examples. It left me. Anyway, there are lots of different package managers out there in the wild that allow you to manage different packages for different types of applications, different types of programming languages, right? So you can install Helm to manage your Kubernetes YAML manifests as like one Helm chart. And I'm going to go into more detail in a second on what a Helm chart is and how we actually interact with Helm. But first, make sure you actually install Helm. Okay, so you can install Helm here through the script, as well as through Homebrew again, through Chocolatey on Windows, through Scoop on Windows, and through apt on Linux-based, Ubuntu-based operating systems, as there's also a Snap available. Awesome. So go ahead and install Helm. Now at this point, what you should have, just a quick recap, you should have access to Kubectl, you should have access to Docker, you should have a KinD Kubernetes cluster installed up and running, and now you should have access to Helm. Okay, this is my local Helm version that's running right now. Awesome. These are the different components that we will need. And now we can get started with actually installing our Prometheus and Grafana application inside of our Kubernetes cluster. Now I'm going to use a Helm chart that's called the kube-prometheus-stack Helm chart. That's installing both Prometheus and Grafana. Now, if you are looking for Helm charts, you can generally just Google the application that you want to install and then Helm chart, and you might find a Helm chart out there in the wild. There's like an artifact hub here that allows you to find different types of Helm charts from the artifact hub. So not just like random Helm charts that random people generated, but random Helm charts that random people generated, but in a repository list on the artifact hub. I hope you know that was a joke. But anyway, so we're gonna go to the kube-prometheus-stack Helm chart. This is ultimately what a Helm chart looks like. The main components are the chart.yaml file. The chart.yaml file specifies the version of the Helm chart, any dependencies. It's usually something that you touch only when you want to build more complex Helm charts. Then we have, in addition to that, we have gitignore, Helm ignore file. So these are basically ignoring different types of directories, okay? I have to go into detail on that. Then there's usually a README, and the README specifies what kind of prerequisite, what kind of requirements I need to have to actually install and use this Helm chart. It also specifies how to, for example, use this Helm chart. So here's how to use it, how to install the application with the Helm chart. Here's what kind of custom resources in Kubernetes will be installed. We're going to look at that in a second as well. And then here are different ways on how you can actually customize the Helm chart somewhere. Is it in here in this repository? No, it's not in this one. It's not in this README. But generally, how do you customize values or like Helm charts? You do it through a values.yaml manifest. And we're going to look at that also in more detail in a second on how you can use the values YAML manifest to customize values or customize a Helm chart. Basically, everything that's specified here, you can change, you can customize to your needs, to your installation. So to use a Helm chart, what we need to do first is we need to actually add the Helm chart to our like the registries that our local Helm installation knows about. So basically, I'm going to copy this command that says Helm repository add the Prometheus-community repository that is on this link. In this link, there are all of the Helm charts from the Prometheus community Helm repository. Now this command is also in my blog post that's linked below in the description, so do check that out if you're curious about the commands. You could also go straight to the kube-prometheus-stack Helm chart and copy the command from there. So we're going to add that Helm chart, Helm repo add, and in my case it already exists. Now you should have it added to your repository list. Once you have added it, we need to fetch the latest updates, the latest details from the Helm chart. And we do that through saying Helm repo update. And that's updating all of our different Helm charts. As you can see, I have lots of Helm registries specified here. For example, the Aqua security chat repository has all of our different Aqua security related Helm charts. The Grafana one has all of the different Helm charts that are related to Grafana, are published by Grafana. And there are several others that I've tried and used in the past, and then I guess I was too lazy to remove them from my local repository list. Now we have access to it. Now we could go ahead and install the kube-prometheus-stack to our local Kubernetes cluster. However, to do that, we need to customize a few values within Kubernetes, within the Prometheus installation. So I have here my repository. Now this GitHub exporter repository is taken or cloned from the GitHub exporter GitHub account that I came across. It's an account on GitHub. They created a Prometheus exporter. I'm going to go into detail later in this tutorial on what the exporter does. But shout out to the community for creating this GitHub exporter and for making it possible by having it open source for me to use it. Actually, let's look at the license. MIT license, so I should be able to use it. Anyway, so within here, I have monitoring resources and I have here a values.yaml manifest. Now at this point, go ahead and anywhere in any repository directory that you want to use, you can create a new test one, right? Create a new test directory, right? And within here, create a values.yaml file. Okay, we need a values.yaml file in the directory where you're working at. That's the main point. And then within that values.yaml file, you copy paste what I've put into the blog post. So copy pasting this part, okay? This is what we need in our values.yaml file. Why do we need this? Well, we're basically telling that the Prometheus installation should have this value to false because by default it's true. We need it to be false. Additionally, we need script timeout and script interval to be 90 seconds. And then you can also just specify the ServiceMonitor selector to not have anything predefined and the ServiceMonitor namespace selector not to have anything defined. We basically want to make sure that across your different Kubernetes namespaces, Prometheus is looking for service monitors that tell it where to find metrics. And then this is just to make sure that if our application is responding in time, that Prometheus doesn't just go ahead and throw errors. Then for Grafana, we say that the sidecar for Grafana, the data sources should have the default data sources enabled to true. Now, where do you find these values? And again, I'm going to go into more detail, but where do you find these values? How do I know what to do? Well, this value comes from a lot of trial and error in installing Prometheus and reading some documentation and some issues other people had, okay? So a lot of working in a cloud native space and working with these resources and tools is about trial and error, finding what works. Okay, so you want to have that set to false to make sure basically through these values, Prometheus will look for service monitors, and I'm going to tell you later what a service monitor is, in all of your different Kubernetes namespaces. It's going to look everywhere for something, for an application that tells it where to find metrics. Okay, so how do I know these values? How do I know where I take this information from to configure Prometheus? Inside of our Helm chart, we have the values YAML file, right? And we can look Helm selector, ServiceMonitor selector nil Helm values, blah, blah, blah. We're going to look for that, and we're finding it here. Now this is nested. This file, this component is nested within, where is it? Within Prometheus spec, and Prometheus spec is again nested within Prometheus. So you really have to scroll through and see like where in the YAML manifest each component is nested, right? For example, this annotation is within the service, or what else do we have here? Here's Prometheus, or enabled. Prometheus is enabled is true, so Prometheus will get installed by default. And enabled is here nested within Prometheus. So one way we can customize a Helm chart is by creating a new values.yaml file and then specifying just the values that we want to overwrite. Okay, this is how we can ultimately customize the values. So I just told you about ServiceMonitors. What is it? What does it do? Okay, there will be lots of different moving parts that we have here that we have to take care of. So ultimately we have here our container image. Okay, this is our container image. Now this container image is deployed as a running container within our Kubernetes cluster. So this is running container. Running container gets deployed within pod, okay? Doesn't work. Within a pod. We will look at all of this in detail in our Kubernetes cluster, okay? So the container image, once deployed, it's a running container and it's running within a pod. A pod is the smallest unit you have within your Kubernetes cluster. This is our K8s cluster, okay? Now, our application, what it does, what our running, where is it? Here. What our running application does is this container image will go to GitHub and basically from the GitHub API request metrics on a specific repository. This is what we're going to install in a second, right? From a repository. This is a repository. This is ultimately what our application will do. And then this is what happens when we run our container image, our running application, okay? Now, once it's running, we will have an endpoint exposed. And that endpoint is our metrics endpoint with all of the different metrics. That's what I showed you earlier in the beginning. These are the different metrics that are fetched through the GitHub API, okay? And then we have access to them in our running pod, in our container image. That ultimately is what happens. Now I want to access these metrics in Prometheus and visualize them inside a nice dashboard in Grafana. That's ultimately our goal. Now for that, I need to install, here, I need to install in here Prometheus, and I need to install Grafana. Now Grafana will go ahead and scrape Prometheus for metrics. Scrape for metrics. This is what Grafana will do. It won't access my application directly. It will access whatever Prometheus has access to it. Prometheus is a data source within Grafana. Now what Prometheus will try to do, it will scrape this metrics endpoint from my application. So my application is like at localhost, in my case 192.19171, and at the metrics endpoint, this is where we have ultimately our metrics. This is here, right? But Prometheus can't just go ahead and scrape it. Now, it needs to do this. It needs a ServiceMonitor. This is another resource that's just as a helper, kind of a Kubernetes resource deployed as part of Prometheus later on, as a helper to tell Prometheus where to find it. Okay, so this is our ServiceMonitor. And the ServiceMonitor is a crucial component because it tells it basically, here, I know where this application is. Prometheus, here are the metrics. So, this is what happens, right? For the ServiceMonitor, Prometheus wouldn't know where this is. It wouldn't know where to discover it within your cluster, right? That's ultimately what happens. So this is what we are building here. Now we are installing Prometheus in Grafana through a Helm chart, and that's something you can see over here. So we have here our demo namespace with our application here installed. This is running within our demo namespace. We have our kube system namespace that I mentioned earlier. And we have our monitoring namespace. We have Prometheus components and Grafana components then installed. And we are going to install it through the Helm chart. Now the Helm chart provides all of the logic, the configuration for the container images that run Prometheus and Grafana. This is a container image. The container images will have Prometheus and Grafana. They are all specified in the values.yaml file within the Helm chart. They are all specified within somewhere in here, the container images, okay? I'm not going to change the container images. I'm just going to change some of the configuration. Once I have defined the values that I want to overwrite, zoom out a bit, the values that I want to overwrite, I can go ahead and I can use this file and with this install the Helm chart. Now, if you want to learn more about Prometheus, check out this video by one of the co-founders of Prometheus. It was started by SoundCloud, by one of these engineers. Here's his face. No, he's a really nice guy. So check out his video on Prometheus. He has multiple different videos, so you can actually dive deep into the nitty-gritty details of Prometheus and how to use Prometheus. Anyway, for the installation, again, here you can find all of the values, everything that you need to put into your values YAML file, okay? You can find it in the blog post linked below. And then we've just done that. We've updated our repositories. We already created a monitoring namespace early on. Now we want to install the Helm chart. And this is the command that we're going to use. So this is the command that we're going to use. What does this command do? We actually need to monitoring resources values. So we say Helm and then install the Helm chart. If the Helm chart is already installed and we just want to make changes, it will upgrade the Helm chart. So this is really useful to say instead of Helm install, say Helm upgrade -- install instead. Then prom is the release name, just the name that we're going to give this application package that we're going to install, right? And then we're going to say from the Prometheus community repositories, right? This is added here. This is the name we gave here. We could have given it a different, no, we can't actually give it a different name. Here is the name of the Prometheus community Helm repositories. Here's the same name, right? And it's in the kube-prometheus-stack Helm chart. There are probably multiple different Helm charts in this repository, but this is the one we want to install. And we want to install it in the monitoring namespace that we created earlier. And here are the values that we want to pass in, okay? This is our values YAML file that we've just set up. And then we hit enter. And we wait for the magic to happen. See, our Prometheus Helm chart got installed. You should have a message similar to the following displayed in your terminal at this stage. And then we can go ahead and we can look at what has been installed into the monitoring namespace. And we do that with Kubectl get all in namespace monitoring. Remember earlier when we started the namespace, there were no resources inside. But now, when I say Kubectl get all in namespace monitoring, the kube-prometheus-stack Helm chart installed all of this. Now imagine I would have to install everything manually. So all of the services, all of the deployments manually into my Kubernetes cluster, that's ridiculous, okay? Now, I'm not going to go into details on what deployments, what replica sets, what services, what pods are, but check out my other videos that I did when I created my YouTube channel on those different components if you're curious on learning more on detail. Generally, I'm going to give you an overview right now. So here are the pods. Pods are running either one container or multiple containers. Kubernetes will tell you how many of the containers that are supposed to be running in this pod are ready. In this case, both of these containers have a running status. Then if the pod, out of any reason, had to be restarted, for example, if I go ahead and delete the Grafana pod, it will be a restart here. And then a new H. Now, why would it be restarted? Well, here, the Grafana deployment manages the replica set for Grafana, and it manages the pods within the deployment that are specified within the deployment. Now, I don't know actually in detail how much stuff is defined within this deployment YAML manifest that's within the Helm chart. But basically, this is managing those different components, right? And then ultimately installing the pod for Grafana. So if I delete the pod, the deployment is supposed to spin up the pod again. It's supposed to manage how many pods should be spun up and any other related configuration. So there's a lot we can define through the deployment. Now, what does the service do? The service specifies how we can connect to the pod, because every time I spin up the pod, it has a new IP address. So I can't actually continuously connect to the pod. I would have to reconnect to the pod every time a new pod is spin up. So if the pod dies, my connection is broken. Versus if I connect to the service will ultimately connect to whichever pod is running Grafana. Because it doesn't connect over the IP, it connects through labels. And we're going to look at that later on as well, how that works. Ultimately, this is everything you should be in your cluster. Now again, remember, it doesn't matter, it's not important that you understand the nitty-gritty detail of what I'm mentioning. I'm bombarding you right now with information. And that's okay. So at this point, what we can do is, we can do a port forwarding to, for example, Prometheus, to our Prometheus service. Now we want to have this one, the operated service, running on port 9090, okay? So you copy paste this name, copy, and then we say kubectl port forward, and then in namespace monitoring, we want to have the service Prometheus operated, and we want to port forward port 9090 to port 9090. And this is gonna do a port forward so we can access this service, okay, for Prometheus. Okay, at this point, you should now be able to access on localhost 9090 the Prometheus UI. This is ultimately what you can access now here. Now, similarly, we can open a new terminal and then we can access our Grafana service as well. So if we say service prom-grafana, again, prom is the name of the release that we gave it, right? And you can say kubectl port forward in namespace monitoring. So it needs to know where that service lives. It lives in our monitoring namespace. Service prom-grafana, and we forward it to port 3000. Oh, maybe it's 80. Yes, that works. Okay, so now we can go ahead and we can access localhost 3000 and a -login. The login will appear the first time. So what are the credentials? Well, the username is admin and the password is your release. In my case, it's prom and a -operator. So prom operator, whatever release you gave it, we told the Helm chart that the release of the Helm chart is called prom. That's why this is called prom. And then it's operator. And then we can log in and we can see Grafana. Amazing. So at this stage, again, you should have access to Grafana over localhost 3000. And then we should have access to Prometheus over localhost 9090. This is where we should at this point of the tutorial. Okay, now we're gonna go ahead and we actually deploy or create our application and then deploy it to our Kubernetes cluster. So again, we can give Kubernetes the metrics in our Kubernetes cluster from the container that's running our application, the running container, over ServiceMonitor the metrics to Prometheus. And the metrics are of our GitHub repository that we specify in this section as well. Now, again, I'm going to explain everything in detail as much as I can, or remember. Now, what we need first is we need to have our repository that actually knows how to access the GitHub API. And this is here. Now, I cloned this repository from these lovely folks. So these lovely folks have created a GitHub exporter. And I came across it and I was like, oh, I can use this. But I don't like using Docker Compose. I never really used Docker Compose. I like to just deploy everything to Kubernetes. So I went ahead, I cloned it, and then I created a deploy directory with a deployment.yaml manifest and a service.yaml manifest. We're going to look at both of them in detail in a second. And then I also went ahead and I created my monitoring resources to install Grafana Prometheus with the values.yaml file that we used in the previous section. Then the ServiceMonitor that is telling Prometheus how to find the metrics from that application. And then the Grafana dashboard. So this is all specified here. I will probably update in my clone of the repository. I will update the README. So it's nicer, so it's more up to date and you actually know what you're finding here. But basically that's the nice thing about open source, right? I didn't really have to do much. I just found somebody else's code. I was like, oh, this looks interesting. This looks good. Let's take it, right? Now, I didn't just take anybody's repository, right? If you look at the repository, it has over 350 stars and over 106 forks. So I imagine, and then the last merge update was on May 22nd. May 22nd, not 2022, 2023, right? So I looked at it and I decided I'm going to trust this GitHub repository and use it as well. So here you can see all of the different resources we used. So what we're going to do first is you need to copy paste. Well, actually you need to clone this repository first. If you want to use your own container image. If you want to use your own container image, you're going to go ahead, you're going to create a fork of this repository, and then you need to have this repository locally. Now, once you have the repository locally, you can build a container image, and then you can push it to your Docker Hub or your other container registry. That's one option, if you want to build your own container image. If you want to make changes to how this application works, you can make changes in the code base, in the main.go file, where I think some of the logic lives. You can make changes and then you could create your own container image based on it. Now I cloned this repository and I created a container image through Docker build, through this command, and I put it onto my Docker Hub account. Where's my Docker Hub? Here. My profile. So here is my GitHub exporter. This is the container image that I built, and it has just one tag right now that I pushed. This is what I built based on that container image. Now that we have a container image, what we need to do, we need to define these two resources. The first one is the deployment.yaml file. So you want to create a resource called deployment.yaml, copy paste this code here. That's also specified again in the blog post that's linked below in the description. So copy paste this code. What this code does, it basically specifies we want to run pod of this container image. And here's the container image that we want to run. It's from the Docker registry, from my account on the Docker registry. Here's the container image name, and here's the tag, so the version basically, that of the build of that container image that we're going to use. So this is really important. Now, this repository specifies how we can customize the running application, the running container image. Here are the different things that we can change. And one of them, the first one, is the repos. The repos environment variable, where we can define the different the different repositories that we want this application to track. Okay, so in our deployment YAML file that you should have locally now, right? In your working repository, like for example, where your values.yaml file is, put a deployment.yaml file there as well. And then you specify this, and you need to specify here in the environment variables the vpus or any other environment variable from that list that you want to specify, and then the value. The value is a string. In our case, we want to track my 100 days of Kubernetes repository to access the metrics from there. And then we need a GitHub token. Now, it's generally bad practice to just put a GitHub token into a deployment.yaml file. So don't commit it. Don't commit this to Git, right? So here's just a test value, a placeholder. What are we going to put in here? We need to get a GitHub token that can access, that can read the different information from our repositories. So for that, you're going to go to your account. You're going to go to settings. Here are my different account information. Beautiful. We're going to go to developer settings. Personal access token. Tokens. Generate new token. Generate new token classic. Use your password or authenticate the app, ideally, something else. Give it these 3 access. That's all to access. I think that's all that's needed, pretty much. I haven't actually looked at all of the different metrics that the repository, that the application can track from GitHub, but we just want to access the different metrics, the different information from our repository. We don't want to access information from our packages or gists, like for example, how many gists were created for a user or something like that. We don't need that information. We just need this information. Then we call it tutorial. Okay, I'm going to delete this afterwards. So you're going to generate the token. You copy that token. Then you go to your deployment YAML file, wherever your deployment YAML manifest lives right now. And you replace tests with the token, okay? Now, in one of my next YouTube videos on my channel, I will show you how you can actually manage Kubernetes secrets in Kubernetes more securely, better than just specifying it right here, right? You shouldn't do this. You shouldn't commit this not to Git. Don't do it, okay? Delete the token. Now, so just be aware of that, okay? This is nothing you should commit, because then people can have access to your repositories. Anyway, so now that we have the deployment.yaml manifest, we want to also have a service.yaml manifest. You can put both of them in a separate directory or keep it in the same directory as your values.yaml file. It's your choice. But we basically need the deployment.yaml file and we need the service. Now the service specifies the port that we're going to connect to of our container image. So this is our container image, right? And here we say the container port that's exposed in that container image is 9171. Where does this come from? Well, this port is exposed in a Docker file. It all comes together. Here, this is the port that's exposed. So we need to say in the deployment, this is the container port that we have. And this is also in services, this is the same port we connect to. It all comes together. It's all connected, okay? So within here, we have a selector, GitHub-exporter, gh-exporter. Now this selector connects with this label. Here, match label. Now, labels here, with the metadata labels, GitHub exporter, right? So through that, the service is connecting through the deployment. Through that, the service knows where the deployment is, where the pods are, independent of which pods, like if they die exist, the service will still be able to connect to it, okay? That's ultimately the goal here. So now that we have both, we can install both. Now something else that's needed here is we need also a label for the service. And I will show you that once we get to the ServiceMonitor. But install the deployment, install the service. So we need a new terminal, okay? Because the other two are running Prometheus and Grafana, and then we need a new terminal. And we're here in that repository that you cloned. And in my case, I have specified everything, the deployment and the service in the deploy directory. So you can go ahead and you can say Kubectl, apply, file, in the deployment directory. You can say deployment.yaml manifest, and we want to deploy it to the demo namespace, okay? So you could go do that. you could also go ahead and you can just say you want to, since in this directory there's only the deployment.yaml and the service.yaml, you can install everything at once. You could do that as well. Now in our case, we're going to say the deployment should be installed first, and then we want to create the service as well. So service. So this both has been created now. So if we go and we check everything in the namespace demo, we will have here our service that we just installed. We have our deployment. Now the deployment manages the replica set and manages the pod. Okay, that's defined within our deployment YAML manifest. You don't have to install this separately. This is defined within the deployment. This is the deployment we just installed. This is the service we just installed. Okay. Now at this point, looking at Prometheus, opening status targets. It doesn't know yet. It can't scrape information from our GitHub exporter. It doesn't get any information from here yet. It can't, okay? There's no information that Prometheus can access yet because we need a service monitor. Now, as part of making Prometheus work, Prometheus is not part of the Kubernetes default API. It's extending the Kubernetes default API so it can run Prometheus. And as part of that, we can install additional resources, such as called a ServiceMonitor. The ServiceMonitor monitors our services, as it says, in our Kubernetes cluster. We can tell it which services to monitor. So anywhere in your repository, create a ServiceMonitor.yaml manifest. And within that, copy-paste this. You can copy-paste it directly from the GitHub repository that I've shown you, or from the blog post. It's both specified there. Now here we need to specify, and we want to match the labels. This is again important, match the labels so it can find which service it should track. Then which port it should connect to, and the path on that port. Because it's not just the default one. No, we want to track /metrics, and the scrape timeout is 90 seconds. Now, we are going to go ahead and we're going to install the service monitor now. So in our terminal, we say kubectl, apply, file, monitoring resources, service monitor, in namespace demo. Okay, this is going to create a service monitor. Now, once it's installed, you should be able now to see the service or the endpoint being scraped in Prometheus. Now this will not be instant. It might take some time. You will have to refresh localhost 1990, and then you should see here your GitHub exporter. Now right now it hasn't been scraped yet, so you have to wait a little bit longer for it to be scraped. Now in this case we have a scrape timeout to basically, and also the scrape interval is higher because our application is not as responsive as it should be. So we needed to increase it to 90 seconds. The default is 30 seconds. So we're going to wait until it's scraped. So again, take some time. And then once it's scraped, we have access to the metrics. Now, where are the metrics? That's the next step we can do in the meantime while we wait for Prometheus to access the metrics. In our demo namespace, right, we have the service GitHub exporter, and that runs on this port, 9171. So we can say kubectl port forward in namespace demo 9171 to 9171. Okay, so we are now port forwarding the service to our application. Now if I go ahead and I just open localhost 9171, I see GitHub Prometheus metrics exporter. Here's the repository for it, where it comes from, and here are the metrics. And the metrics just basically lead me to the -metrics endpoint. And here are all of the metrics. Now these are the metrics from the repository that I specified in the deployment environment variable. So remember, if in the deployment I specify I want to track this from this GitHub organization, this might be your GitHub username. I want to track this repository. So within here on my GitHub account, right, I have my 100 days of Kubernetes GitHub organization. And within here, I have my 100 days of Kubernetes GitHub repository, where I want to extract the metrics from, right? Now let's check back in with Prometheus. And it successfully scraped the metrics endpoint. So now what we can do, we can go to Graph, and we can say GitHub stars, and we can run the query. And here you will see the metrics that it has this many GitHub stars on the repository that we're tracking. And there's lots of other information on where these metrics come from that allows us, for example, if we have multiple repositories we are tracking, we can filter then by the repository. So we could say we want to only track the specific repository. So we have access to all metrics in Prometheus. Yay! So how do we now build our dashboard in Grafana? Well, we have access here to Grafana, right? Port localhost 3000. Just make sure we have access to it. Right now, we only have access to our default dashboards. These are the default Kubernetes dashboards that this comes with. Now we want to create a new dashboard. New dashboard. And then you can create your new dashboard. This is your new dashboard. Now we want to go ahead and we go to dashboard settings. And we name this dashboard GitHub Metrics Dashboard. Okay, and then we go to JSON model. This is the default dashboard. It doesn't have anything in it. No. So, everything within panels. So you copy everything that's under panels. This is everything within panels. Copy everything in here within the panels, right? So this dashboard is in the GitHub repository. Then you go to your JSON model and you go to panels here. And you paste your panels right here. This is where you paste it. Okay, you replace the panel section. Make sure that it's correctly indented. Save changes. Correct. Save dashboard. No changes to save. Okay, dashboard. And then we can see our metrics. Woo! So, you might, if you have chosen to track another GitHub repository, you might have to edit the name of the repository because your repository name will be different than mine. Mine is called 100 Days of Kubernetes. Yours might be called different. So you have to edit this dashboard. You could then also go ahead and you can play around with it. You can make a table of sorts. And then it will show you over time. Or you can make a time series graph and then see how the number of stars go up or down over time. So you can build your metrics here, your different queries. You can say a new query, select metrics. So in this case, GitHub. We can say, for example, even the number of forks that we want to track, right? And then we want to track that in our repository. And then we can see here the number of forks as well. Number of forks, repository forks. Now you can play around with it by creating dashboards. You can also, within Grafana, you can go to the explore section and you can build and run different queries here without building a dashboard. It's very exciting. So do check that out. So as a recap, what have we done? We first went ahead and we installed Docker on your device. We then installed Kubectl. We then installed KinD to spin up a Kubernetes cluster. Now it should have connected automatically to Kubectl. We installed Helm locally. Then with Helm, we installed the kube-prometheus-stack Helm Chart. Here, we customized the Helm Chart. We learned how to customize the Helm Chart. From there, we then took somebody's repository and we created a container image. I've stored that container image here in my Docker Hub account. Anybody can access that container image. We created Kubernetes deployment that specifies the container image we want to use, how we want to use it with environment variables, which repository we want to track. We created a service for that to connect to the deployment and to visualize, to look at the metrics here of the deployment. We had access to Prometheus, made sure that our targets work. We have access to Grafana. We are able to create a new dashboard in Grafana. And that's all just connecting through Prometheus to our application through a ServiceMonitor. We learned about ServiceMonitors as well. So monitoring resources, ServiceMonitor. Here you will also find the Grafana dashboard to use. All of this in this amazing tutorial. Now again, you can find everything within this blog post. It's linked below in the description. Now as you can imagine, again, this took a lot of time to prepare and to create and to record and everything. So please do give this video a thumbs up to make sure that other people see my content as well, and subscribe to my YouTube channel for upcoming videos. Now, I really hope to see one of my next videos. This was amazing to create, to prepare, and to post. So I really hope you enjoyed it. I really hope it was useful. Again, you don't need to know the nitty-gritty details of everything I said or understand the nitty-gritty details of everything that I just said. Just use this tutorial as a starter tutorial. Look at Docker commands, look at how you manage Docker container images, look at other container runtimes, explore and try out other container runtimes. What's the difference between them? How do you use one over the other? When do you use one over the other? All these details is something that people might ask you in job interviews as well. Look at the different Kubernetes components. How are they put together? What are different ways you can run a Kubernetes cluster other than through KinD that I showed you in this tutorial. Watch the video, the live stream that I've recorded with Hannah, where she goes into all of the different details, the different components that I need to run Kubernetes, to manage your resources. Look at Prometheus related resources. Try out maybe another Prometheus exporter, another application, and scrape metrics from that. Apply the ServiceMonitor to another exporter, to another service, and scrape the metrics endpoint from there. You just have to make sure there's a metrics endpoint that you can scrape from. So basically, by applying these resources to other applications, to other resources, you can learn and iterate upon it and understand it in more detail of how everything is connected, because everything is ultimately connected, which is really exciting. Now, this is it for me for today. I really hope this long tutorial was useful to you. It was definitely interesting to prepare, and I learned something new in preparing it. So do leave your suggestions for upcoming videos in the description, in the comment section below. Really hope to see you on one of my next videos. Subscribe to my channel for upcoming videos. Have an amazing day. Bye bye.